We're starting Chapter 3 in Thinking Mathematically. Chapter 3 is on logic. So since some of you have not had any experience working with logic, I'm going to try to give you a few extra videos for the different sections of this chapter. This one is Section 3.1, Statements, Negations, and Quantified Statements. It looks like we have a lot of objectives, but don't worry. Identify English sentences that are statements, express statements using symbols, form the negation of a statement, express negations using symbols, translate a negation represented by symbols into English, express quantified statements in two ways, and write negations of quantified statements. So first we're going to define a statement. A statement is a sentence that is either true or false, but not both simultaneously. Examples include, London is the capital of England, which is a true statement, and William Shakespeare wrote the television series Modern Family, which is a false statement. In logic, we often want to have not statements. So commands, questions, and opinions are not statements because they're neither true and false. You have to be able to distinguish between statements and not statements. Examples, Titanic is the greatest movie of all time. This is opinion. Read pages 23 to 57 is an order or a command. If I start losing my memory, how will I know? That's a question. In math, we can use symbols to represent statements. We use the lowercase letters such as P, Q, R, and S to represent statements. We're going to let P represent the statement, London is the capital of England, and Q represent the statement, William Shakespeare wrote the television series Modern Family. Now we're going to look at negating statements. The negation of a true statement is a false statement, and the negation of a false statement is a true statement. In this example, we're going to form the negation of each statement. The statement A, Shakespeare wrote the television series Modern Family. Okay, this is not a true statement. So the negation would have to be true. We can say Shakespeare did not write the television series Modern Family, or we can say it is not true that Shakespeare wrote the television series Modern Family. There are a number of different ways that you can form negations. Continuing with this example, we want to form the negation of today is not Monday. Again, there's more than one way to do it. You can say it is not true that today is not Monday. That's the use of double negatives, which can sometimes be confusing. Or we can just simplify it and say today is Monday. Example 2. Now we're going to express negations symbolically. We're going to let P represent the statement Shakespeare wrote the television series Modern Family, and Q represent the statement today is not Monday. We want to express each of them symbolically. So if we want to do the negation of P, we would say Shakespeare did not write the television series Modern Family, and we denote that with a little wavy line in front of P, which is read the negation of P. For the negation of today is not Monday, we would say today is Monday, and we would write this as the negation of Q. Quantified statements. The words all, some, and no or none are quantifiers. Here's some statements containing a quantifier. All poets are writers. Some people are bigots. No math books have pictures. Some students do not work hard. And I think you can identify the quantifiers in each of these statements. This chart or table shows equivalent ways of expressing quantified statements. If we have the statement all A are B, we can also say that there are no A that are not B. Examples: all poets are writers. There are no poets that are not writers. These are two equivalent quantified statements, all or there are no poets that are not writers. For the statement some A are B, an equivalent way would be to say there exists at least one A that is not B. Examples: some people are bigots. At least one person is a bigot. Going to the statement no A or B, an equivalent way to say this would be all A or not B. Examples of two equivalent quantified statements would be no common colds are fatal, or all common colds are not fatal. And finally, some A are not B. And an equivalent way to express this would be not all A are B. Examples: some students do not work hard, not all students work hard. So we're looking at the negation of quantified statements. The statements diagonally opposite each other are negations. So if we have all A are B, or there are no A, there are not B, then the negation of that would be some A are not B, or not all A are B. For some A are B, or there exists at least one A that is a B, going diagonally opposite, the negations could be no A are B, all A are not B. And here are some examples of quantified statements and their negations. Now, again, like in a previous video, some of these illustrations are a little hard to read, so you may want to download the PowerPoints from the lessons or from the course menu so you can look at them more closely. So for the left example, the statement is all writers are poets. So we've got the circle that contains all poets, and we've got a circle inside it, a subset basically, that has writers. So this is showing that all writers are poets. The negation is some writers are not poets. And we can show this with these two circles. You have poets, you have writers, you've got some overlap, but the part over here that is pointed to by the arrows says some writers are not poets. It's not included in the poets circle. Looking at the other diagrams on the right side of this slide, we see again two circles. One represents canaries, the other represents 50-pound objects. And the statement is that some canaries weigh 50 pounds. So this would be the intersection of those two circles. The negation of this would be no intersection. So we would have the circle of canaries, the circle of 50-pound objects. So this shows that no canary weighs 50 pounds. Example 3, negating a quantified statement. The mechanic told me all piston rings were replaced. I later learned that the mechanic never tells the truth. What can I conclude? Let's begin with his statement. All piston rings were replaced. Because this mechanic, not all mechanics, this particular one, never tells the truth, I can conclude that the truth is the negation of what I was told. The negation of all A are B is some A are not B. So you can conclude that some piston rings were not replaced. Or you can also conclude that at least one piston ring was not replaced. This is using all those previous examples we had of forming negation. And that completes this particular section in the book.